Okay students, so welcome back to my channel, Density Classes, and in today's video's lecture we are going to continue with class 11 chapter 4 chemistry, and the topic which we are going to start today is we have done up to covalent bonds. Now today is in today's lecture Lewis dot structure we have already discussed in previous lecture. If you have not watched the lectures and if you have till now you have not subscribed the channel, then please, dear students, dear friends, go to my channel Density Classes, subscribe the channel, and then you can get the previous two lectures which I have given on this chapter. Now today we are going to start with the formal charge. Okay, so let's start with the formal charge. So today's topic is what? Formal charge. FORMAL, formal charge. CHARGE, charge, formal charge. Okay, so first of all let us understand what is the formal charge. So formal charge is nothing but basically formal charge, it is represented as FC. Formal charge, it is represented as FC, and it is the difference of number of valence electron minus number of lone pair of electron and minus half of shared pair of electrons. Shared paired electrons. Okay, that is represented by S. Okay, so here the formula of formal charge is what? Formal charge equals to the difference between the valence electrons, lone pair of electron, and half of shared pair of electrons is called as what? Formal charge. Why is formal charge important and all those things we will discuss it. See, formal charge basically tells us about the one which will have the lowest energy. Okay, that one will have the lowest formal charge. So that basically formal charge gives us the information about the energy of that particular structures. Okay, so the elements which will have the lowest energy, that is lowest formal charge, they will have the lowest energy, and lowest energy means the stability, the bond stability will be higher, because low energy, so there will be no repulsions, no much attractions. So that means that structure will be stable structure. But if that if any structure has higher energy, that one how we'll know? We'll know with the help of a formal charge. If the energy of any structure is high, that means that particular structure, Lewis dot structure, is not stable. Okay or not? So that information is given to us by formal charge. In Lewis dot structure we have seen some structures are like this, some structures are this way, right? Some structures will be this way, this way, this way. So different structures are there. Which structure is most stable, which will be told to us by formal charge. Which one will be most stable? The one which has the lowest formal charge, they will have the least energy, and as a result they will be having the as a result they will be the most stable one. I hope you have understood what I am trying to tell you. Okay, got it? Okay, so now let us start to find out how to calculate the formal charge and what are the things here, what are the meaning of those symbols. I will tell to you. See here V indicates, here you can write here V is equals to valence electrons, okay, and here L is lone pair of electrons, okay. Lone pair of electron, we can say in other word, unused electrons. Okay, dear students, unused electrons. Some of you might be wondering what is lone pair of electron, what is unused electron. If you are wondering about this, dear students, don't hesitate, go to my first video lecture for this chapter. You will come to know what is lone pair of electrons, because there I have explained chemistry chapter 4 class 11. Okay, I have explained what is lone pair, shared pair, and all those things. You can watch from there. L equals to lone pair of electrons, that is unused electrons, those electrons which are unused. Then the S equals to shared pair of electrons, shared pair of electrons, shared pair of electrons, that means used electrons or bonded electrons, you can say bonded electrons. I hope this point is clear. So formal charge is basically nothing but the difference between the valence electrons, lone pair, and shared pair of electrons. It is why we need to calculate the formal charge. We need to calculate the formal charge in order to find the stability, in order to find out whether the Lewis dot structure which we have drawn, it is stable or not. If it is unstable, the structure may change. So whether it is stable or not, how we will know? We will know by the formal charge. If the formal charge is less, then energy also will be less, the stability of that structure. That means that structure will be correct structure or perfect structure for that particular compounds if formal charge is low. If the formal charge is high, that particular structure may not be the perfect one. It may change because of higher energy. They may start repelling or attracting someone else, which may lead to the change in structure. Okay, dear students, so hope this point is clear. You have noted it down. Now we will do some questions on it. Okay, so quickly pause the video and take down. Okay. Now we are going to find out formal charge of find out the formal charge of question. Suppose find the formal charge of Ogen, OZ or any Ogen, O3. So we are asked to find out the formal charge on O3. So before going for formal charge, how to find out the steps I'm telling to you, try to learn it properly. This topic is very important. So first of all, I have already taught you in the last videos the Lewis dot structure. If you have not watched, please go to my channel Density Classes and watch lecture number 2, part 2 of chapter 4, class 11. There I have discussed the trick how to draw the Lewis dot structure. So Lewis dot structure, if you want to draw, we will be drawing it like this. Okay, this is oxygens, and here it will be 6 to 18. So here it will be double bond, here it will be double bond, and 2 to 4 8, and here it will be 4 4 4 4 4 4. Okay, so 4 and 4 4 and 4 8, and here it is 8. So 8 and 8 16. Okay, so Lewis dot structures, and again 2 more will be here. Here it will be left. Okay, fine. Now we are asked to draw the Lewis dot structures of this one. Okay, so Lewis dot structures, when we are drawing, how we will be doing it, let us see. Fine, so this is the Lewis dot structure of ogens. Now we'll mark this oxygen as 1, this oxygen is 2, and this oxygen as 3. So one by one we will start calculating the formal charge on that oxygen, each oxygen. So first of all, let's calculate the formal charge of oxygen 1. Formal charge of O1, oxygen 1, equals to valence electron. So oxygen, the valency is how much? What is the number of valence electron in oxygens? Valence electron means number of electron present in the outermost shells. So in oxygens, the number of electron present in the outermost shells will be how much? What is the atomic number? 8. So 2 6. So 6 will be the number of electrons present in the outermost shells. So V will be 6 minus lone pair of electron. Lone pair means, I told you, it is unused electron. So in these oxygens, what is the unused electron? This is the unused electron. So how many are there? 2. So we'll write here 2 minus half of shared pair. Shared pair means those electrons which are used in forming the bond. So here 2 electrons, here 2 electrons, here 2 electrons. So total number of bond is how much? 3. So each bond is formed with the help of 2 electrons. So total number of electrons, shared pair of electrons will be how much? 2 2 2. So it will be 6. Got it? Understood? Okay. So 6 minus 2 is how much? 4, and 2 3s are 6. So 3. Then what is the formal charge we are getting? Plus 1. So the formal charge of this is how much? Plus 1. Oxygen 1 formal charge is how much? Plus 1. Fine. Now let's move on to the formal charge of oxygen 2. So we'll write here formal charge of O2. So formal charge of O2, when we are writing it, formal charge of O2. So this is also oxygens. So what will be the valency? Valency will be same. It will be 6 minus. What is the number of lone pair here? 2 4 6. Unused electron. These are called unused electrons. So it is 6. So 6 minus half shared pair. How many bond it is sharing? It is forming only one bond, so 2. So you will see 6 minus 6 0, and it will be minus half into 2, it will be equals to minus 1. So the formal charge here is how much? Minus 1. The formal charge on oxygen 2 will be how much? Minus 1. Hope dear students you are understanding it. Now we are going to calculate the formal charge on third one. Okay, so formal charge on third one we are going to calculate. So we'll write here formal charge of O3. So formal charge of O3 formula is what? Valence electron. So valence electron is same, 6, oxygen only. So lone pair, here lone pair are how much? 4, and minus half into shared pair. How many bond it has formed? 2, and 2 bond means how many total number of electrons will be there? Each bond it is made up of 2 electrons. So 2 bonds means how many electrons? 4. So it will be 4, 2 2s are 4. So it will be 6 minus 4 minus 2, which is equals to 6 minus 6, which is equals to 0. So the formal charge here is how much? 0. So we got the formal charge of all the 3 oxygens atom. This is how we calculate the formal charge. Hope dear students you have understood it. Okay, if you have understood, you can pause the video and take down. Okay, so the next questions we are going to do is calculate the formal charge on phosgene. So what is phosgene, dear students? Let me tell you, you will study in detail in class 12. Okay, the uses and how it is prepared and all I will tell you. Phosgene is nothing but it is a, you can say that derivatives of chloroform. Okay, phosgene is nothing but it's a derivative of chloroform. When chloroform is oxidized, okay, when chloroforms comes in contact with the atmospheric light or atmospheric conditions, it changes into phosgene. Okay, when chloroform comes in contact with the light, okay, sunlight, it changes into phosgene. That is the reasons this chloroform it is kept in a, not in a transparent bottle or not in a, you can say that a white bottle. It is always kept in a colored bottle so that the light ray does not falls on it, because the moment it comes in contact, this chloroform comes in contact with the light, it will form a phosgene gas, which is very, very poisonous. Okay, this gas is very, very poisonous gas. Okay, but it's a poison only. So phosgene. So now we will, first of all we have to draw the Lewis dot structure of phosgene gas. Then only you can calculate the formal charge. So for calculating, what we have to do, as I have told you, first of all you have to calculate what? Total number of valence electrons. Total number of valence electrons. So total number of valence electrons will be how much? Carbon ka valence electron is 4 plus oxygen ka 6, chlorine ka 7 into 2. So it will be 10 and this is 14. So total number of electrons we have 24 electrons. So now we will draw the electronic configurations. Okay, before drawing the electronic configurations, first I told you while not electronic configuration, before drawing the Lewis dot structure, I told you in the trick that first of all you have to select the one which is least electronegative. Okay, so here oxygen ka electronegativity is higher than carbon, and oxygen ka this chlorine ka electronegativity is higher than oxygen as well as carbon. So the least electronegative is which one? Carbon. So carbon will be in the center. So carbon will be in the center, chlorine, and oxygen will be like this. Got it? How I came to know that carbon will be in the center? Dear student, again I am telling you the electronegativity among all these is least for carbon. As a result, carbon will be considered as the central metal atom. Okay, others will be surrounding. Okay, again I am telling you, we have to select the one which has the least electronegativity, and that one which has the least electronegativity, it will be in the center and others will be surrounded. Okay, so carbon has the least electronegativity, so it is in the center. And as I have already taught you in the previous lecture, if you have not watched, please go and watch part 2 lecture of chapter number 4. Okay. So see here, I have drawn single bond here. Total number of electrons I have 24. So out of 24, how many electrons I have used? 2, 2, 2. So it is 6 electrons used. And now first of all we have to complete the octet of outer electrons with how many electrons remaining? How many are there? 6. So 2 2 2 6 8, then 2 2 2 6 8, and then 2 2 2 2 6 8. So I have completed the octet, okay, of the surrounding atom, and all the 18 electrons I have used. Now we don't have any extra electrons. So what we will do, but the next step is what? We have to check the octet of central metal atom. So central metal atom is what? Carbon. So 1 2 3 4, only 1 2 3, only 6 electron it has, but as per the Lewis dot structures, or as per the Lewis octet rules, we should have 8 electrons in the outermost shells. So these carbons, what it will do, it will go for forming a double bond with the oxygens. So it will form a double bond with the oxygens, and it will be having now how many electrons? 2 4 6 8, 8 electrons it has. Okay, so this is how the Lewis dot structure is drawn for phosgene gas. So we have drawn the Lewis dot structure. Always remember, dear students, in your competitive exam also questions may come for formal charges, but you should know how to draw the Lewis dot structure. If you don't know how to draw the Lewis dot structure, then the difficulties will start. Okay, so you should know how to draw the Lewis dot structure, or else how. Okay, so already I have taught you. If you are not learning, then what we can do? Okay, so we have drawn the Lewis dot structure, and after drawing the Lewis dot structure, what is our next rule? Our next work is to mark it. 1 2 3 4. We have marked all the atoms, we have given the number, and after that we will start calculating one by one their formal charges. Okay, so pause the video and take down the structure first. Okay, so I hope you have taken down. Now we shall start the calculation. So formal charge. So first we are finding out this chlorine and this chlorine will have same formal charge. So we will calculate for one, and that will be the same for other also. Formal charge of Cl1 and Cl3. Both formal charge we are calculating. So what is the formula for formal charge? Come on, tell. V minus L minus half into S. Right, this was the formula. So V is what? Excuse me. So valency of chlorine is how much? What is the number of electron in the outermost shell of chlorine? Chlorine atomic number is 17. So outermost 2 8 7. So outermost it will be chlorine atomic number is 17. So what will be the electronic configuration? 2 8 7. 8 10 7. So 7 is the valence electron. So number of valence electron in chlorine is 7. So we'll write here 7 minus. What is the number of lone pair of electrons it has? 1 2 3 4 5 6. 6 electrons are here, which is unused. That is called as a lone pair of electrons. Minus half into shared pair. Shared pair means how many bond it has formed. It has formed only one bond. That means for formation of one bond, how many electrons is required? 2 electrons. So we'll write here 2. 2 cancel. 7 minus 6 1, and here you have cancelled, then 1 minus 1 is 0. So what will be the formal charge of this? The formal charge for this will be 0, and the formal charge of this chlorine also will be 0. Okay, hope point is clear. Now we are going to calculate the formal charge for oxygens. So we'll write here formal charge of oxygens. So oxygen's formal charge, it will be equals to how much? Same formula, V minus L minus half into S. So V is how much? Oxygen ka valency is how much? The number of valence electron for oxygens. Oxygen atomic number is 8. So valency will be what? 2 6. So 6 is the number of valence electrons. So 6 minus, what is the lone pair? 4. 4 minus half into shared pair. How many shared pair of electrons are there? 1 bond, 2 electrons. 2 bonds, 4 electrons. 2 bonds are there, so 4 electrons. So we'll write into 4. 2 2s are 4. So 6 minus 4 is 2. 2 minus 2 is 0. So here also formal charge we are getting 0. Okay. Got it? So if you want to calculate the formal charge of carbon, we can calculate it, the formal charge of carbon. Since I don't have space, so I am writing here and there. Dear students, when you take it down in the notebook, you take it down in a proper sequence. Okay? Okay. Don't write like this, thinking that sir is writing like this, so I'll write like that. So formal charge of carbon, it will be equals to V minus L minus half into S. I'm writing the formula every time so that you can memorize it. So valence, what is the valency of carbon? Carbon number of atoms is 6. So what will be the valency? 2, 4. So number of valence electron is 4. Minus, is there any lone pair? No. So there is no lone pair here, right? Dot is not there, so 0. Minus shared pair. How many shared electrons are there? 2, 4, 6, 8. 4 bonds, so 8 electrons. So 2, 4. So 4 minus 4, it will be equals to 0. So here also the formal charge is 0. Okay, that means this structure is very much suitable structure, most appropriate structure there, because their formal charge are all 0. They will have what? Minimum energy. So this one is considered as stable structure. Okay, dear students, hope you have understood this. Okay, pause the video and take down. Okay, dear students, so formal charge, I have taught you how to do it and how to calculate the formal charge. So regarding the formal charge, I have given you 2 small questions. I am giving you calculate the formal charge on CO3 and NO2 negative, that is carbonate and nitrate ions. You have to calculate the formal charge, and after calculating, if you get the answer, you can write your answers in the comment box and you can tell to me, and I will check how many of you have done it correctly. Okay, so this is your assignments. Okay, so you will be doing it, calculate the formal charge on CO3 negative and NO2 negative. Okay, now coming to the next topic, exceptions to the octet rules. So octet rules we have studied, but octet rules also has certain drawbacks, certain certain exceptions were also made in the octet rule. The first exceptions was what? The first exceptions made was hydrogen molecules exceptions. In octet rules, exceptions of hydrogens were made, hydrogen molecules. What was the exceptions? We'll discuss now. Hydrogen molecules. So what is the exceptions made here? As you know, hydrogen's number of atoms is how much? 1. So hydrogen, it needs only 1 electron. So if you draw the electronic configurations for these hydrogens, the circles, so it will be nucleus and this is the outermost. So this is K shells, right? All of you have studied in class 9-10 that K shells capacity is only 2 electrons. Okay, so 1 electron already hydrogen has. Now 1 electrons only it will take from other. So it is having how many electrons in the outermost? It is having 2. But according to the octet rule, what it should have to attain the stability, it should have 8 electrons, right? But with this 2 electron itself, so this hydrogen is capable of attaining what? Attaining with 2 electrons only, hydrogen is capable of attaining what? Stability. Okay, it is capable of attaining the stability with the 2 electrons. Okay, got it? And it forms it is having the noble gas stability of helium, He2. Okay, got it or not? So in this case, it was exceptions were made that okay, hydrogen molecules, no problem. In order to attain the stability, it does not need to have 8 electron. With 2 electron also the stability can be attained. So this was the first exceptions in the octet rule which was made. I hope you have understood, because hydrogens, it has its atomic number is 1 and it needs only 2 electrons to complete its octet. Got it? And this case not octet to get its stability. So here with 2 electrons only the stability is attained. So here octet rule is what? Compromised. Here octet rule is what? Here some exceptions were made in the octet rule in case of hydrogen molecules. Okay, dear students? Okay. So here, what in case of hydrogen molecules, octet rule is not needed to attend, okay, octet rule is not needed to achieve, let's write achieve, okay, achieve the stability. So this was the exceptions made here. In hydrogen molecule, octet rule is not needed to achieve the stability, okay, or you can say stability or the stable electronic configurations. Stability, or you can write stable electronic configurations, okay, to attain the stable electronic configurations. Got it? So this was the first exceptions which is made in the octet rule. The second exceptions which was made in the octet rule was what? The second exceptions was made incomplete octet of the central metal atoms, okay. The second you can say the second exception was incomplete octet of central metal atoms, okay. So incomplete octet of the central metal atoms, for example, you can see like LiCl. If LiCl is there, lithium, okay, so it has a number of electrons, 3 electrons are there, okay, outermost it has only 1 electron. So if you draw the Lewis symbol of lithium, so it will be like this, and chlorine ka Lewis symbol, it will be like this, right? So among these two, which one is the least electronegative? Lithium is the least electronegative, so lithium will be central metal atom. Okay, lithium is least electronegative, so lithium will be the central metal atom, and now they will be sharing electrons, they will form a bond. So in this case you can see only chlorine is attending the octet, whereas lithium is not attending the octet. So this one octet, he was not able to explain this, okay, he was not able to give the solid reasons behind why this octet is not complete, okay, or not. He could not explain properly why some of the central metal atoms, they do not complete their octet, okay. That was one major setback for these octet rules, okay. Got it or not? Okay, fine, done, okay. Another example, if you see for central metal atom, it is BeH2, BeCl2. In all these you will see central metal atom, they will not complete, incomplete octet they will have, okay, incomplete octet. So this one was not addressed by octet properly. In octet rule, this was exceptions were made. These two exceptions were made in the octet rule, and in some, okay, one more exception is there. That one also let me discuss. The third one, okay. So then you can pause the video and take down the things, okay. Now I will rub it. We'll go to the third point, exceptions which was made by octet. The third exceptions which octet made, okay, was expanded octet of the central metal atoms. The third exception is expanded, okay, octet of the central metal atom, expanded octet of the central metal atom, okay, expanded octet of the central metal atoms. What does it mean? It means that in some cases you will see that the octet of the central atom is more than 8, okay. In this case the octet is more than what Lewis octet rule says. For example, SF5, if you see SF5, phosphorus valency is what? Phosphorus atomic number is 15, okay. All of you should remember, I'm telling you again, atomic numbers. Phosphorus atomic number is 15, so it is 2 8 5, right? So valency is how much? 5. Fluorine is 9, so it will be 2 7. Valency is 7. Okay, got it? So if we draw the Lewis dot structure for this, you will see that S will be in the center, F F F F. So here 1 2 3 4, 1 2 3 4 5 6, 1 2 3 4 5 6 7, 1 1 2 3 4 5 6 7, 1 2 3 4 5 6 7. So it is forming one bond here, one bond here, one bond here, one bond here, and let's assume one more bond. It will not assume, it will form one more bond here, because fluorine is how much? 5. Got it? So this is how SF5 structure it is drawn. SF5. In case of SF5, you see the central metal atom, according to octet rule, they should have how many electrons? 8 electrons. But now look at how many central metal atom has electrons? 2 4 6 8 10. So here also Lewis dot structures could not explain. Here also Lewis dot structure fails. Okay, because the central metal atom has what? Expanded octet of the central metal atom. Here central metal atom has more electron than prescribed by octet rule. So here also octet rule has failed. So these are some of the drawbacks of what? Octet rule. So these are the 3. More are there. Let's not discuss it much. So these are the 3 main octet rules drawback or the exceptions. Okay, so if it comes in the exams, dear students, don't hesitate. Sir has already given you, so please take it down and write it well in your exam. So next we are going to shift to the general properties of the covalent compound. Before that, pause the video and take down the notes. Okay, dear students, so now let us see the coordinate covalent bond. What is coordinate covalent bond? Let us try to understand coordinate. Okay, coordinate covalent bond. Covalent bond. Okay, so we are going to understand this coordinate covalent bond. Okay, this coordinate covalent bonds and all this coordinate covalent compounds, you will study all this in class 12. For time being, just you have to understand what is coordinate covalent bond. So coordinate covalent bonds are those bonds, it is a kind of covalent bond. My handwriting is very bad, you please forgive me. So it is a kind of covalent bond which is formed, okay, which is formed by the which is formed when both the shared electrons, when both shared electrons is given by single atoms. Okay, so it is a kind of covalent bond which is formed when both the shared electrons is given by a single atoms. Okay, that means here we have seen that covalent bond was what? In covalent bond we have seen that both the suppose hydrogen's electrons and chlorine, suppose here one electron is given by hydrogen, one electron is given by chlorine, so the bond is formed. This is covalent, this is called covalent bond. But in coordinate covalent bond you will see that both the electrons, it will be either given, suppose this one, both the electrons will be given by whom? By one atom. So the bond which will be formed by giving in which both the electron is given by one atoms, that bond we call it as what? Coordinate covalent bond. And it is represented by, it is denoted, okay, it is denoted by arrow. This is the sign of coordinate covalent bond. Okay, this is the sign of coordinate covalent bond, where tail, where tail, this is tail, okay, where tail is pointed towards the donor and arrow, or you can say arrowhead, and head is pointed towards whom? The head is pointed towards the acceptor. Got it? So once again, let me read it out. What is coordinate covalent bond? It is a kind of covalent bond which is formed when both shared pair of electron is given by a single atom. Okay, this point is clear. Both the electrons to form the bond will be given by one single atoms. So that bond which will be formed is called as what? Coordinate covalent bond. I will show you. It is denoted by what? It is denoted, this coordinate covalent bond is denoted by an arrow like this. Okay, where tail means this one is pointed towards the donor. This tail will be towards the donor, the one which is giving two electrons to form the bond, and head is pointed towards the one who is accepting that two electrons from others. Getting my point? So let's take an example. So for this one, formation of, you can say formation of NH4 positive. Okay, we are going to take an example of NH4 positive. This one, how it is formed, let us take the examples. Okay, so we know very well NH3. So NH3, right? So N, here H, here H, here H. This is NH3 and two electrons are there here, lone pair of electrons. Okay, this is lone pair of electrons. What? Nitrogen's valency is what? Nitrogen's atomic number is 7, so valency is 2, 5. So 5 is the valency, 1, 2, 3. 3 electrons and 2 here, 5. Got it? One electron is given by hydrogens and 1 electron is given by nitrogens to form these bonds. Okay, again I am telling you, if you don't have the clarity, please go and watch the first 2 videos, then only you will understand this. Okay, okay. So this nitrogen has 5 valence electrons, so 3 electrons is used for forming bond with hydrogen, 2 electron is left unused. Okay, now when this ammonia, when it is combining with H positive, now H positive is what? Hydrogen has only 1 electron, and that 1 electron also it has already lost. Now this hydrogen is left with no electrons, it does not have any electrons. Okay, whereas this nitrogens, it has got 2 extra electrons. Now nitrogens really wants to form a bond with H positive. Okay, so what it will do, what will be the conditions? The nitrogens, it will be asked, okay, nitrogen will say to hydrogens, will you form a bond? Then hydrogen will say that I don't have a single electron, how can we form a bond? Nitrogen will say, I have a solution, I will give you both my electrons and we shall form a bond. So that bond which it will be formed, because here nitrogen only alone it is giving 2 electrons, so the bond which they will form in between them, it is called as coordinate covalent bond. So how it will be, let's see. So it will be like this, H, H, H. So who is donating the electrons? Nitrogen. So the tail will be towards nitrogen. Who is accepting the electrons? H positive. So it will be like this. Got it, dear students? So this bond we call it as what? Coordinate covalent bond. So this is your coordinate covalent bond. I hope you have understood, dear students. It's very easy and very simple as well. So you have understood. Coordinate covalent bond definitions we will study in this class, and class 12 we will study about the coordinate compounds. All those compounds which form like this kind of bonds, we are going to study about it in class 12. Okay, dear students, so pause the video and take down. Okay, so dear students, for today the video has already crossed 40 minutes. So I don't want to bore all of you, so I will conclude today's videos, and in the next class we are going to do the bond parameters. Okay, Got it? So bond parameters, I will be doing it in the next class, that is bond length, bond angle, bond order, all these things we will be discussing in the next class, which is very very important for your all the exams points of view. Some of the students, I have seen that you are simply forwarding the videos and you are watching it like this. Watching the videos, it will not help you, dear students. Start the video properly from the beginning and watch it till the end, then only you will understand something, then only this video will be helpful to you. Okay, so please do it. And till now, if you have not subscribed the channel, don't forget to subscribe my channel, Density Classes, and don't forget to share the videos with your friends, okay, so that they also can know about the chemistry, they also can develop their interest in the chemistry. I have seen many of the students during this lockdown, they are suffering because they don't have the proper explanations, and especially in English. Okay, most of the YouTube channels we have in Hindi and English mixed, but here we are providing purely English explanations. So share with your friends in Nagaland or any part of the India, so that they also can get a benefit of these videos. And if you are getting a benefit from these videos, dear friends, please don't forget to subscribe, like and share my videos with your friends. Thank you so much. Study hard.